talk about a complete revolution in how we think about aircraft safety. That's what the global aviation industry spends every single year on maintenance, and a massive quarter of that is spent just on structural issues. This isn't just some line item on a budget. It's a huge drain on resources, on efficiency, and on readiness, and it absolutely hammers the bottom line. Let's start with the challenge itself. The way we're doing things now, our current approach to structural health, it's being pushed to its limits. You see, the real heart of the problem is something you can't even see. It's the threat of invisible damage. As we've all moved toward these incredible lightweight composite materials to make our aircraft more efficient, we've accidentally introduced a brand new vulnerability, damage that can threaten the entire structure without leaving a single mark on the surface. This is the stuff that keeps engineers up at night. We're talking about delamination, where the internal layers just start to separate, or matrix cracking, these tiny microfractures deep in the resin. You could have a minor impact from a bird strike or even a ground vehicle, and on the outside, everything looks fine. But deep inside, critical fibers could be snapping, creating damage that grows silently until it leads to catastrophic failure under normal flight loads. And that really brings us to the core disconnect, doesn't it? Our traditional methods are reactive. We wait for a scheduled check, maybe every few thousand hours, to send people out to manually hunt for damage. But what we desperately need today is a system that's the complete opposite. It needs to be automated, continuous, and predictive. A system that tells you there's a problem the second it starts, and one that isn't affected at all by the electromagnetic interference that can throw off conventional sensors. And that leads us to the financial impact, which is just brutal. That's in lost revenue, logistical nightmares. It's a massive price to pay for flying blind between inspections. So, now that we've really defined the problem, let's talk about the solution. And I want to be clear, the absolute best way to think about this technology is to imagine giving your aircraft a nervous system. Seriously. A complex network of sensors that can feel every bit of stress, strain, and temperature change across the entire airframe instantly and with perfect precision, just like our own bodies. So here's how that works in practice. It's actually beautiful. We send a pulse of light down the fiber. The FBG, that tiny mirror, reflects its own unique color right back to us. And here's the key. If the aircraft swing flexes or the fuselage feels some strain, the fiber itself stretches just a tiny bit. That stretch actually changes the FBG, which in turn shifts the color of the light it reflects. By measuring that tiny, tiny shift in color, we can calculate the physical strain on the structure with absolutely incredible micron-level precision. This technology is backed by tons of aerospace research, demonstrating over 95% accuracy in finding cracks as small as a single millimeter. How do we turn this elegant principle into a real-world practical solution? How do we take all that raw data and transform it into intelligence your maintenance and engineering teams can actually use? This table connects all the dots perfectly. That huge problem of hidden damage, we solve it with continuous, real-time strain mapping. Those inefficient, time-consuming inspections, they get replaced with condition-based predictive maintenance. You only fix what needs fixing when it needs fixing. EMI and false positives? Gone, eliminated. And those data gaps that lead to expensive over-maintenance? We fill them with AI-driven models that can tell you exactly how much life is left in your critical parts. The financial benefits are huge. We're projecting a 20 to 30% reduction in your overall maintenance costs. And that's not just a guess. Those savings come directly from getting rid of unnecessary manual inspections, from dramatically cutting down those costly AOG events, from safely getting more life out of your components, and from optimizing your entire repair cycle based on real data, not just the number of hours in the air. And these benefits ripple out across your entire fleet. We are talking about enhancing safety with near-perfect damage detection. We're talking about extending the service life of your multi-million-dollar assets by 15 to 20%, increasing your mission readiness by slashing inspection downtime by up to half. And you'll be supporting your sustainability goals because you're only replacing parts when they actually need to be replaced.